All right, so last time we took a test, so that means new stuff this time. So today we are going to start our unit on exponential functions and logarithmic functions. All right, so today is just exponential and we're just getting our feet wet. We're going to keep it pretty basic, okay? So we're just going to look at how to basically deal with these things and kind of what they are, okay? So an exponential function is a function whose variable is in the, shocker, exponent. Okay. That's an M. Exponent. Okay. So exponential functions are functions with variables in the exponent. So, is 2x an exponential function? No, that's a linear function. 2 to the x, however, sure, because the variable's in the exponent. Here's the one that confuses people sometimes, x squared. Nope. Okay, not an exponential function. That's a polynomial function. Okay, because x is not the exponent, x is the base, so that's not okay. Now, this 4 to the x plus 1, while there's that plus 1 up there, that x is still in the exponent, that's exponential. Okay, pretty simple. So exponential functions have an x variable in their exponent. All right. Now, if you remember, there's a few rules of exponents that we need to go ahead and remember and make sure we're good with. So first of all, let's just look at an example. So given the function f of x equals 4 to the x, evaluate each of the following. Okay, so if I say f of 2, that means I want to take 2 and plug it in to my exponent. Okay. 4 squared is 4 times 4, which is 16. Okay. F of 1. So I need to take 1 and put it into my exponent. Anything to the first power is itself. Okay. So let's go ahead and find that one down here. So anything to the first power is itself. Okay. All right, f of 0. So that's going to be 4 to the 0 power. Anything to the 0 power always is 1. Okay, so anything to the 0 power, no matter what it is, if it's raised to the 0 power, it's 1. Okay? All right, here's where things get a little more fun. For me, not for you. All right, so maybe, possibly, there we go. All right, so 4 to the 1/2 power. All right, anytime you have a 1/2 power or a fractional power at all, that means that we're going to do a root, okay? So since this is 1/2 and not like 1/3 or 1/4, this means we're going to do a square root. If it was a 1/3 up there, we would do a cube root. A 1/4 would be a fourth root, and on and on and on, okay? So this is the same thing as the square root of 4, which we should know is 2. Now you might be thinking plus or minus 2, but remember that only happens when you like take the square root of both sides of an equation, okay? If we're just saying what's the square root of 4, the square root of 4 is 2. All right? So anything to a fractional power is a root. Okay, be that a square root, a cube root, a fourth root, on and on and on. All right, and lastly, if I have 4 to the negative third power, all right, what a negative power does is it flips the base, all right? So if I have 4, this now becomes 1/4 to the third power, okay? Now let's say it started out as 1/4 to the negative third, it would have flipped up to regular 4 to the third power, okay? So if it's not a fraction, it becomes a fraction. If it is a fraction, it becomes not a fraction. There's something that makes sense in there, I think. Okay, so then that's 1 over, all right, 4 cubed, 4 squared, 16. 16 times 4 is 64. All right. So anything to a negative power is a fraction. All right. Now, of course, that is unless it's already a fraction, in which it becomes a regular number, but I'm going to protect you on that. Okay. Now, when we're doing exponential functions, if you remember back with Miss Frederick last year, okay, or some of you, Mr. Carroll, there is a number that pops up a lot with exponential functions that is kind of like pi, okay? So this number is e. All right. A good estimate for e is 2.74. All right, just kind of keep that in your head. Now, what e is it is a number that occurs in the world, okay? It has a lot to do with physics and wave movement, wavelength, all of that stuff, which means it has a lot to do with like music also. All right. It's tied closely with things that also involve imaginary numbers, which we talked about earlier this year. Okay. It occurs, it's like the ratio in some plants that happen. Okay. We call it the natural base because it happens in nature. All right. So E is just a thing that if you take any higher level physics class, you will see all the time. So we got to talk about it. Okay. So E behaves just like any other exponential function. If I would have said e to the 0 power, that would have been 1. If I would have said e to the first, that would have been e. Okay? So e is just a special number that behaves the exact same way. So if I want to put these expressions in order from least to greatest, remember our our estimate for e is 2.72. So this is going to go 2 squared. That's not a 2. Let's try that again. 2 squared. And then it'll be e squared. And then it'll be 3 squared. Right? So 2 squared's 4. 3 squared's 9. So that's how you could kind of figure out that e squared is somewhere between 4 and 9. Now that's a pretty big range, but honestly it's the best we got. So it's good enough. Now you're actually not going to be asked to evaluate e all that much, but it'll pop up when we solve equations and when we simplify some things and all that kind of stuff. Okay. Our last little thing here are these basics of all exponents, okay? But we're going to apply them to exponential functions. So if I take and I multiply two things with exponents, if they have the same base, I'm going to add their exponents. If I divide two exponentials with the same base, I am going to subtract their exponents. Okay? And if I'm going to raise a power to a power, I'm going to multiply those two exponents. Okay? All right. So let's use those rules to go through and simplify each of these things to the best of our ability. Okay? So 2e to the x plus 3e to the x. All right, if I'm adding, now there's not a property for this up here, but it's just kind of common sense. If I'm adding two things with the same base, I'm just going to add those numbers out in front. So this is going to be 5e to the x. Okay, because I can just add those things. Now looking here, I'm subtracting these two, okay, but they don't have the same power. So there's nothing I can do. I have to just leave that. Okay, you can only add or subtract these things if the powers are the same. Okay, now let's look at multiplication and division. If my screen wants to refresh and make it nice, there we go. Okay, so if I'm going to multiply these two exponentials with the same base, what I'm going to do is I'm going to keep the base, and then I'm going to add their exponents. So this is going to be 6 to the power of x plus 7. Okay? The thing that people do wrong here is that they would try to multiply 4 and x plus 3. Okay? That's not what we do. If I am multiplying things with the same base, I add their exponents. Okay? Similarly, if I'm dividing two things with the same base, I'm going to subtract their exponents. So this is going to be 4 to the 2x minus 1 minus x plus 5. Okay, notice I put that x plus 5 in parentheses because I'm subtracting the entire quantity. So that's going to be 4 to the 2x minus 1 minus x minus 5 when I distribute the negative. So that is going to be 4 to the x minus 6. Okay? All right. Now our last little property was, if I am raising a power to a power, I multiply those two powers together. So this is going to be e to the x plus 2 times 3x. Okay? So this is e to the 3x squared plus 6x. Okay? If I raise a power to a power, I multiply those two powers. All right, a couple more. All right, on this one, these things don't look like they have the same base. Okay? However, they do share a common base of 2. Because I know that 4 equals 2 squared. Yes? So here's what I can do. I can say, all right, well, this is 2 to the second power times x minus 3 times 2 to the x plus 4. Okay? Because what's happening here is 4 is 2 squared, and then I'm going to raise that to the power of x minus 3. When I raise a power to a power, I multiply their exponents. Okay? So this is 2 to the 2x minus 6 times 2 to the x plus 4. If I multiply two things with the same base, I'm going to add their exponents. So this is 2 to the 3x minus 2. Okay? All right. Last one. Now again, at first glance, these two things do not have the same base. However, they do share a common base, and that common base is 3. Okay? 27 is 3 cubed. 9 is 3 squared. So this is 3 to the 9x minus 6 divided by 3 to the 2x plus 2. If I am dividing two things with the same base, I'm going to subtract their exponents. So this is 3 to the 9x minus 6 minus, in parentheses, 2x plus 2. Okay? So if I distribute that negative, I get 3 to the 9x minus 6 minus 2x minus 2. which is 3 to the 7x minus 8. So fun. Why would I put that minus 8 on the bottom? Who knows? Let's go and try that again. Minus 8. All right. All right. So those are our properties of exponential functions. Okay, all the basics. Next time we will go through solving equations with these properties. All right. Then we will start